So this is just a preview of 2.6. If it seems so a little confusing right now, remember, this is just me starting to show you a few little things. This isn't the end all be all of the lesson. I'm not even giving you your practice yet. This is just giving you the ideas that are happening. So the first thing I want to talk about is, what is an asymptote? An asymptote is a line that a graph approaches. So if I look at the graph 1 over x, I see asymptotes of the y-axis, as it looks like this graph wants to shoot down the y-axis, then it comes down from the top of the y-axis here. So it never looks like it actually crosses the y-axis. That's an asymptote. The x-axis is also an asymptote here. Again, it looks like it's going really close to it, but no matter how much I zoom out, it doesn't look like it ever actually crosses my x or y axis, right? So that's the general idea of an asymptote. So we have two types. We have a vertical asymptote and we have a horizontal asymptote. So let's start with vertical asymptotes. So a vertical asymptote, I'm just going to abbreviate that with VA, happens when you set the denominator equal to 0. So we're not allowed to divide by 0, right? Whenever we divide by 0, that gives us an error. That's where we're going to get gaps in our graphs. There is one exception to this, and that's when things cancel out and create a hole. We'll talk about holes tomorrow. Now, to find our horizontal asymptote, we're going to look at the following. If I have A times x to the n over b to x to the m, there are two scenarios. If n and m are equal, that's a little more complicated. But if this has a higher power in the denominator, it's easy. So if m is greater than n, it's just going to be y equals 0. And think about it. If I have something like 1 over x, x has a higher power than 1. If I put in a huge number like 10 million, 1 over 10 million is incredibly small, right? If I told you had a 1 in 10 million chance of winning something, it would be like, whatever, that's like nothing. That's why it goes to y equals 0. It's going just to approach the x-axis. Now, if we know that m is equal to n, something special happens here. It's going to now become y equals a over b. So I'm going to look at some scenarios here, and I'm going to do this. So let's say I have 1 over x minus 3. I want to know where my asymptotes are. So my horizontal asymptote is easy. This has a power of 1, or this doesn't even have a power, doesn't even have an x variable. The x here has a power of 1. So the x is greater than no variable at all. So that's just going to be y equals a. And watch this. If I say y equals, not y equals a, y equals 0. If I put y equals 0 in there, I'm going to make it a dashed line. Notice it looks like it just wants to hang out around this dashed line, right? You know, that's our asymptote. It approaches the dashed line, but never crosses it. Now for the denominator, our vertical asymptote. What I want to do there is say x minus 3 equals 0. Well, that's a super easy equation to solve, right? Add 3, x equals 3. So that's what I'm going to type for my other asymptote. We should see it appear in this gap between the graphs and kind of split it. X equals 3. I like to make my asymptotes dashed lines, so it's obvious they're not part of the graph. There are guides to the graph. So notice again, this just wants to hang out with these lines. Now let's pretend I solved this wrong. Let's say I said, oh, it's x minus 3, x equals negative 3. Watch this. If I put a negative in here, this doesn't look like it's in the right spot, does it? It's like, oh no, it looked right between these graphs when it was in the correct spot. Now I accidentally typed it in wrong. It looks way off. Now it returns to where it wants to be. That's example 1 I want to show you with asymptotes. Let's look at example 2 very quickly. Let's say here, whoop, there's my cursor. I'm going to change this numerator to 2x plus 5 and change the denominator to 3x. I'll just keep it as x minus 4 now. And actually, I'm going to zoom out a little bit. But my asymptotes look way out of whack right now, right? I see it already crossing this green line. The purple line looks okay, maybe, but I have to zoom out to inspect that more. So, for my horizontal asymptote, what I'm going to do is, this is 2x plus 5 over x minus 4. Now, if I start putting huge numbers in here, if I had 10 million plus 4 or 10 million minus 5, would that make much of a difference to a really huge number, just adding 4, subtracting 5? No. You guys are correct. That's not going to do much at all. So essentially what I'm going to do is ignore that part. I'll just look at it as 2x over x. Well, 2x over x will reduce to just 2. So that's going to be y equals 2 for my horizontal. Okay, this looks much better placed. Now the other one, again, x minus 4 equals 0, add 4, and we get x equals 4. Now for this, with the size of this graph, unfortunately, it's not the most visible right away, but this looks a little better. If I zoom out, oh yeah, that's working for me. My asymptotes appear to be in the right place. It looks like neither of these curves want to cross those lines. That's a preview of the ideas. This right here is a quick statement and summary of the big ideas. We're going to talk about it more tomorrow. We're going to look at it a little more in depth tomorrow. But I wanted you to get a preview and an idea of what's coming, because I know that this isn't going to be the easiest. This recording will be posted. Stop recording. Yes.